Today we are going to discuss factoring completely. The first step is to always look for a greatest common factor. If one is there, we need to factor that out first. In the example below, there exists a greatest common factor between the two terms of this binomial. The greatest common factor between 3 and 15 is 3. The greatest common factor between x to the 6th and x to the 3rd, or the most x's that both terms have in common, is x to the 3rd. Once we factor out the greatest common factor, we need to figure out what's left. After I factor out 3x to the 3rd from the first term, x to the 3rd remains. Once I factor out 3x to the 3rd from the second term, I ask myself, what times 3 will give me 15? 5. Since I factored out all 3 x's, there are no x's left to remain. The final thing I look at is what's inside my parentheses. There is no more factoring that I can do inside the parentheses, so this is my final answer. Next, we will factor a trinomial with the leading term x squared. This type of polynomial will factor into the product of two binomials. The first term in both of those binomials will be x. To factor this trinomial, we will need to determine two numbers that multiply to negative 24 and add to negative 5. To do this, we'll list the factors of 24. 1 and 24, 2 and 12, 3 and 8, 4 and 6. Once we examine our list, we notice the difference of 3 and 8 is equal to negative 5. So I'm going to put a 3 and an 8 in my two binomials, and to get those two to add to negative 5, I will need this to be a positive 3 and a negative 8. My final check, 3 times negative 8 gives me negative 24. 3 plus negative 8 gives me negative 5. I have factored this trinomial. As we look at this next example, we again notice that there is no greatest common factor between the two terms. This polynomial can be factored as a difference of perfect squares. It also can be rewritten as x squared plus 0x minus 16. If we were to factor this polynomial, we would be again factoring this polynomial as a product of two binomials. The first term in each binomial is again x. We need to find numbers that multiply to negative 16 and add to 0. The factors of 16 are 1 and 16 and 4 and 4. The pair that we will use are 4 and 4. To get the 4 and the 4 to add to 0, one will need to be positive and one will need to be negative. We have now factored this polynomial. The reason we can call this a difference of perfect squares is because the terms are subtracted and both the x squared and 16 are perfect squares. If you can recognize that a polynomial is factored as a difference of perfect squares, you can factor the x squared as x and the negative 16 as positive 4 times negative 4. In the next example, we again examine for a greatest common factor. There is no greatest common factor between 9 and 25, and since we are working with different variables, there is no greatest common factor between our variables. At first glance, it may look like we cannot factor this polynomial. However, if we notice, 9 is a perfect square, x squared is a perfect square, 25 is a perfect square, and y to the 4th is a perfect square. I can factor this polynomial as a product of two binomials. The square root of 9 is 3. So we split up the 3 into both of our binomials. The square root of x squared is x. If we remember from our previous example, the signs inside the parentheses are positive and negative. In our second term, the square root of 25 is 5, and the square root of y to the 4th is y squared. The final example is a quadratic equation where I must solve for x. In solving the quadratic equation, it is essential that you get the equation equal to 0. The next step is to factor the left-hand side. Again, we will look for a greatest common factor, which happens to be 3. When I factor out a 3, I am left with x squared plus 4x plus 4 is equal to 0. Immediately, I should notice that inside my parentheses, I have a trinomial that I can factor again. This kind of problem is an example where you will need to factor twice. I write the 3 and then factor the trinomial as a product of two binomials, still equal to 0. X squared plus 4x plus 4 factors as x plus 2 and x plus 2. In my factored form, I have three terms that are being multiplied together to equal 0. I will use my zero product property, which says if three terms are multiplied together to equal 0, to solve this equation, I will split my factored polynomial into three parts. 3 will never equal 0. When will x plus 2 equal 0? X plus 2 will equal 0 when x is equal to negative 2. X plus 2 will equal 0 when x is equal to negative 2. This equation has two answers. However, both answers are the same. X equals negative 2.